Then I learned the shortcuts for factoring two special products, perfect square trinomials and difference of squares. Starting with perfect square trinomials, this expression, remember, is equal to this. We learned how to factor things by using double distribution. So that would be r squared minus 3r minus 3r plus 9. And then that would simplify to r squared minus 6r plus 9. So if we're simplifying, that's what we get. But since it's a perfect square trinomial, we could use a shortcut. The shortcut is, I'll wait for you guys to catch up. Has anybody been listening to my recordings? Can you hear them better now that I've been using the microphone? Anybody know? Not getting able to listen to them? Can you hear them better since I've been using this? A little bit? That's what I needed to know, so I'll keep doing it. As long as it's not a little bit worse. All right. So here, if we want to use the shortcut, lost my pen. If we want to use the shortcut, all I do is look at the binomial. Remember, so the shortcut is equal to the square of the first term. Now I take negative 3 times r and multiply it by 2. So negative 3 times r, negative 3r times 2, negative 6r. And I square the last term. So it's negative 3 times negative 3, that'll be plus 9. Not a whole lot less work, but it is a little less work. Really the most important thing is that you recognize that it is a special product. Sometimes that will help when we're factoring to solve quadratic equations later. Just helps to be able to recognize those. So let's look at another example. Now we're just going to use the shortcut. So x plus 4 squared. X plus 4 squared. We're writing that example in our notes. So we're going to square the first term, multiply the two terms, and then multiply them by 2. 4 times x is 4x, times 2 is 8x, it's a plus, so it's plus 8x. And then we square the last term. We're always squaring the last term. Any questions on the shortcut there? All right. You guys write that one. Can anybody use the shortcut and tell me the product? Riley, can you tell me use the shortcut and give me the product of 2n plus 5 squared? 10n times 2, right? So what's 10n times 2? Perfect. Perfect. Square the last term. So you don't have to write this question, but what do all the products have in common? So the products, what they all have in common, Clarence? Okay. So they all have in common a perfect square first term, perfect square, perfect square, perfect square. They all have a perfect square last term, which means that it's going to be positive, by the way. can't be positive if it's not it can't be a perfect square if it's not positive. And the middle term for all is 2 times the product of the terms in the binomial, right? That's what they all have in common. That's how we multiply those with this shortcut. So now, instead of giving us the binomials to square, we use the shortcut. Now they're going to give us the perfect square trinomial, and we have to give them the factors. So, to do that, the first thing we need to do is be able to recognize if it's a perfect square trinomial. So in order for it to be a perfect square trinomial, it has to have, like we just said, perfect square first term, perfect square last term. The third term has to be, the last term has to be positive, and the middle term has to be twice the product of the terms in the binomial. And I actually do have a checklist. So this is our example. And before we use the shortcut, we're going to check to see, is it a polynomial, or is it a perfect square trinomial? If it's a perfect square trinomial, then we can use the shortcut to factor it. So let's see how this works. Oh, there it is. All right, so this is what we want to check. Is it a perfect square trinomial? So if it's a perfect square trinomial, the first term will be a perfect square, the last term will be a perfect square. You wrote all the steps, the questions down, Ira? Huh? You wrote all this? Sorry? You guys caught up with me? All right, let's look. Is the first term a perfect square in this example? What do you think, Caleb? Is z squared a perfect square? Yes. So for So we're going to put number 1 is yes. How about, is the last term a perfect square? Claire? Yes. 6 times 6 is 36. That makes 36 a perfect square. Is the middle coefficient equal to 2 times the square root of the first and last term? So that's going to require us to take the square root of the first term times the square root of the last term times 2. So that equals 12z. So the answer is yes. So if that's the case, we can use the shortcut to factor. So what is the shortcut? I'm going to show you and then we'll write the steps. So the shortcut to factor is a perfect square trinomial. That means we're going to have one binomial squared. So we're going to give ourselves that blank binomial raised to the second power. We're going to take the square root of the first term and put it in the first spot. The square root of the last term, you writing this down, Winston? And put it in the last spot. The operation in our binomial factors here is always the operation, the first operation, the operation on the middle term. So z plus 6 squared is equal to z squared plus 12z plus 36. That make sense, Caleb? All right, so I have steps for factoring. And all right, so to factor, we're going to give ourselves the blank binomial, but it's got to be squared. Then this should be first term. The first term is this in the binomial is the square root of the first term in the trinomial. The last term is the square root of the last term in the trinomial. And we're going to use the first operation in the trinomial as the operation in our binomial factor. So we are going to use these steps and do one other example. So once you get that example written, we're going to go ahead and look at this example. All right, what do you think? Looking at our steps to figure out, is it a perfect square trinomial? Is the first term a perfect square? Is the first term a perfect square? DeAndre, is this first term a perfect square? Okay, so let me give you a hint first. Before you say no, is this number 9, is that a perfect square? Is there a number you can multiply by itself to get 9? Yes, so that's 3 would be that number, so that's a perfect square. Can you multiply y times y to get y squared? So that makes that a perfect square. So that is a product of perfect squares there. So we're going to say yes to number 1. Now, is the last term a perfect square? Tyler says yes. Tyler's right, because 4 times 4 gives me 16. And the third's a little bit trickier. So is the middle coefficient equal to 2 times, so we're going to start with 2 times the square root of the first, the square root of 9y squared is 9y, times the square of the last, times 4, that equals 12y. So, I'm sorry, 24y, 12y times 2. So it does equal the middle term. So now we know the answer here is yes. So now we can use the shortcut to factor. So the shortcut says, give yourself a binomial squared, and then we're going to fill it in. What's going to go in my first spot? Dior, what's going to go in the first spot? Y. Is there something else that's going to go with the Y? So remember, this is going to be whatever's in this first spot's going to get squared, right? Yes, 3y. So it's the square root of the first term. The square root of 9 is 3. The square root of y squared is y. So it's 3y. The last term is the square root of the last term in the trinomial. So what's going to go in the last spot, Bonami? Yep. And the first operation in the trinomial, I should say, is the operation in the binomial factor. So what's going to be the operation? Addition or subtraction? Caleb? Yes. Good job. And that's how we square it using the shortcut. Anybody have a question on that? Did you just get to school, Marquise? Did you just come to school? Okay. Okay, now we are going to talk about difference of squares. So we're going to go to the title Difference of Squares. Difference of squares. We're not going to do that. We're not going to like that. So these are the factors. So a difference of squares is a special product. So to see what it looks like, we're going to multiply r minus 3 times r plus 3. We're not going to use our shortcut first. R times r equals r squared. R times 3, remember, equals 3r. We're going to multiply everything in both parentheses by everything. Oh, that's wrong. So it's plus 3r minus 3r, which is 0, right? So this is the difference of squares. So r squared minus 9. So perfect square minus perfect square. Difference means subtraction, right? Has to be a binomial. So we could use a shortcut here. We learned that if we have two identical binomial factors, that we could use a shortcut to factor it, or to multiply it. So if there's two identical factors except one is subtraction and one is addition, rather. So if that's the case, we can square the first term. A difference of squares is always going to be subtraction, so it's going to be minus the square of the last term. 3 squared is 9. So without doing the distribution and combining like terms, we get our product. That's special product that is a difference of squares. This is a binomial product. It's the only binomial product that you can get from multiplying two binomials. Normally, if you multiply two binomials, you get a trinomial, maybe a four-term polynomial, right? But this is the only time you're going to get a difference of squares or a binomial as a product if you're multiplying two, because that middle term is going to disappear. It's going to disappear because one is subtraction, one is addition, but in every other way they're the same. So we're going to use our shortcut here. Two identical factors, except one is addition and one is subtraction. Two identical binomial factors. Can anybody use a shortcut and tell me what the product would be? Is that you, Clarence? What'd you say? That's it, exactly. So two binomials, the only way to get a binomial product is if they are a difference, if the two binomials are exactly the same except one is addition and one is subtraction. Okay, so if we know that an expression is a difference of squares, then we can use the shortcut to factor it. And in these, it's pretty important because if you don't have any idea about a difference of squares, you're going to think this is not factorable, right? You're going to only look for a greatest common factor. Marquise, take your AirPods out. Pick up a pencil and write. Tyler, pick your head up, buddy. Got to pick your head up, pen in hand. Marquise, your AirPods out, pen and pencil, or pencil and paper. All right, so we want to factor this. But before we do that, we need to double check that it is a difference of squares. So how do you tell if it's a difference of squares? Dadnabbit. Here we go. Here's our questions. Is this a difference of squares? And this is what we're writing now. It's a pretty quick check. It takes a lot longer to write these steps to check it. It's pretty quick. I want to make sure you have something in your notes so when you get home, if you need help, you can go back step by step. Normally, most people will look at this and go, oh, nope, no greatest common factor, can't be factored. No more, baby. You can only drink water in here. What's that? Well, don't do it if you know. Marquise, there's nothing on your paper, on your table, your desk. Well, then ask for a piece of paper. I'll try to find you one. Somebody around you might have a piece of paper as well, Marquise. I had paper yesterday. I don't know where my paper is. Does anybody have a piece of paper Marquise can have? Thank you, Riley. Alright, so looks like most of you are caught up. So let's look at this expression, x squared minus 100, to see if is it a difference of squares. So is it a binomial with subtraction? Yes. So, yes. Is the first term a perfect square? Yes. Is the last term a perfect square? Yes. So we can factor using the shortcut. So the shortcut is you're killing me, Jilla. And we're running out of time, so I'm going to go ahead and put the steps for you to copy. All right, so the steps to factor, we're going to give ourselves two empty parentheses. So that's what we're going to do here. Put the square root of the first term in both spots. So the square root of the first term, x squared times, or x times x gives me x squared, so that goes in both spots. Put plus in one and minus in the other. Yep. Clarence, yes? We're not there yet, but it's going to be. And then put the square root of the last term in both last spots. So Clarence says that's 10. He's right. The square root of 100 is 10 because 10 times 10 gives us 100. We do always have to check to make sure there's not a perfect square or a greatest common factor. So we're going to do this one other real quick example before we pack up. Once you get the steps written, these are the factors. So this is the answer to this example. But one other example, it'll literally take us 30 seconds to factor now that we know the steps. So, you caught up with me, Caleb? All right, so let's go to write this example in. Last thing we're going to do. Before I look to see, is this a difference of squares? I'm always checking no matter what I do, is there a greatest common factor here? Is there a greatest common factor in these terms? What do you see? A 3, right? So we can rewrite that as 3 times n squared minus 1. So my answer, now, this was not a perfect square trinomial, but now this part is not a perfect square trinomial, but a difference of squares. Because it's a perfect square minus a perfect square. 1 is a perfect square, 1 times 1, and squared is a perfect square, n times n. So perfect square minus perfect square, it's a binomial, so now we know it's a difference of squares. So now I'm going to give myself 2 empty parentheses. In the first spot goes the square root of the first term. Put addition in one, subtraction in the other. The last thing is to put the square root of the last term in both spots. And so that is the factors of 3n squared minus 3. Even though the beginning expression wasn't a difference of squares, one of the factors was. So to factor it completely, we have to factor the greatest common factor up and then factor the difference of squares.